I would love to introduce our next speaker. Our next talk actually is a panel. It's being moderated by our VP of Marketing at Snorkel AI, here to talk about adopting data-centric AI at enterprise scale. Please join me in welcoming Devang Sachdev.
Thanks, Aarti, and hello, everybody. We're going to talk about adopting AI at adopting data-centric AI at enterprise scale. And having spent some time with working with Fortune 500 organizations, both at Snorkel and at NVIDIA and Twilio prior, I know it's really challenging for large-scale organizations to adopt new technologies. But joining me today are two veterans who have championed change within some of the world's largest organizations within the banking and consulting industry. So it is my privilege to have Sourabh Deb, who's helping Citi Bank harness the power of AI across many divisions, and Richard Finkelman, who is a nationally recognized expert helping Fortune 500 clients apply machine learning solutions in disputes, compliance, and financial services industries. So please welcome Sourabh and Richard.
Good morning.
Yep. Morning,
Richard. Morning, Sourabh. Thanks for joining you both and taking our time to talk to us about adopting data-centric AI at an enterprise scale. Sourabh, maybe starting with you, if you could just tell us a little bit more about what you do at Citi, and Richard, the same question for you after.
Yep. Thanks, Devang. Thanks for having me here. So I'm Sourabh. I'm part of the AI Center of Excellence at Citi. So our remit is to further the adoption of AI ML technologies across the bank. And as part of that, we are interested with developing and designing policies, procedures, risk and control guidances to ensure these technologies are used in a safe and sound and reliable manner across the bank, and ensuring the processes are consistent when these are developed and implemented in production. So prior to Citi, I was with consulting and advisory roles, especially in the areas of process engineering, Lean, Six Sigma, robotic process automation, and the likes. So yeah, so happy to be here and looking forward to our talk.
Nice to meet you as well. I'm Richard Finkelman. I'm a managing director at Berkeley Research Group. My practice focuses in the legal area. I've been in law for almost 40 years. I'm not a lawyer, but I could definitely play one on television after spending all this time working with lawyers. We have a joke in our industry that there's two things you never want to see being made. One is law and the other is sausage. So I can tell you that in my experience, helping lawyers with technology is a struggle for a lot of reasons that may be obvious to people who are lawyers because they did not study technology or engineering in law school. And the group I'm in does artificial intelligence and machine learning in disputes and compliance. And so we're building and developing models that predict information, predict compliance failures, and also predict language of legal documents in terms of what lawyers should be looking for.
You can also ask questions of the panelists by putting them into the Q&A tab in your right pane. All right, so first question for Sourabh. Sort of a lot of people say that model is only 10 to 20% of the full AI solution. Would you say that's fact or a fiction?
Yeah, that's an easy one, Devang. So people like us who are in the trenches doing this day in and day out know for a fact that the model development itself is a relatively smaller work effort compared to all the activities that need to happen in the end-to-end AI lifecycle. Right. So, so if you look at the entire AI life cycle, starting from ideation, where you have a business idea, you need to justify whether AI is the right solution or not. So that itself means that you have to go through a couple of iterations, due diligence, maybe do some POCs and pilots. It takes some time to get the fact that AI is the right solution for that. And then you have the next biggest hurdle, which is the data. So you have to identify your sources of data. You have to ensure that the data that you are collecting is fit for purpose. It matches to the objectives that you're trying to solve for. Then all the data pre-processing steps that you would have to do would come into play, and that takes a lot of time, right? So only when all these upstream activities are completed, then you get to your model development part, right? And then once the model is developed, then you have your a plethora of activities that need to be done on your downstream side, which is, you need to ensure, where you're going to implement this model, which application this model would reside. Is it going to run in a static or a dynamic fashion? How are you going to put guardrails on the outputs that the model is going to generate so that it doesn't deviate from a well-defined ranges? How do you scale the model? How do you, ensure it's reliable? How do you, ensure that it's transparent and explainable? So there are a whole set of activities that precede the model development itself, and then the set of activities that are downstream to the model development. And if you happen to be in a regulated entity like us, like the bank, there are tons of documentation that follows an AI lifecycle. So model risk management requires every minutiae of details to be captured, because we have to explain the use of the models to the regulators. And it means that, your transparency, explainability, biasness, how do you deal with biased data, all that has to be documented and captured in your documents. So yeah, so going back to your question, yeah, it is it's a myth. It's model, it's the glamorous portion of an AI ML life cycle. If you ask a fresher that's passing out, they all want to tweak and fine tune the models, play with hyperparameters, and you will see very few takers that want to go and treat outliers or treat missing values and prepare the data. So yeah, I mean, I compare it to an engine in the car, right? So the engine by itself doesn't do much. It needs the chassis, the body, the transmission, the wheels, the fluid. It needs the right fuel for it to run. So in this case, the data is the fuel for the model, right? If you don't give the right data, the model is just not going to work.
That's
I know
great.
it's a long-winded way of answering
No,
your question.
it resonated with me quite a bit. I loved your analogy, how you placed the idea of building an application is all about bringing together sum of parts, and then the essential component in all of this is data. It starts with data, it ends with data, and then model is one way of getting from one type of data to a different type of data. So that's great. Thanks for sharing that. I threw a little bit of a softball to Sourabh, so here's your softball, Richard. Once put in production, AI applications rarely need to change. Fact or fiction?
Well, that's clearly fiction, but don't put me on the witness stand, because some lawyer could cross-examine me and get me to say that it was fact. So the reason I think it's fiction, there's probably 3 or 4 points worth talking about. The first one is, and data scientists are not going to like me saying this, but poor code. And most of us who are the end users have really no idea how to judge that. And poor code doesn't mean it's terrible, it's badly written code. There's so many complexities in how infrastructure is laid out for data scientists to do their job that the code may be fine, but in one of the calls they're making, they're not calling the right thing. And that's very difficult for the layman to understand, that code needs to be updated, code needs to be tweaked. The next thing I would say is that the input people get from the use case people, the end users, can be bad or it changes over time. A good example for us is that we depend on labeling activities, and labeling activities are sometimes ambiguous because you can ask two lawyers to label the same piece of information and they're going to give you two different labels because they can do that pretty easily. So I think that's a big one. The third one is if you've determined your outcome prior to building a model, you're kind of already hosed, because if everybody thinks, hey, this is what the results should look like, then you can actually build bias into your model without realizing it. And so you got to go back and tweak it. And then I think the fourth one is something that you guys are all familiar with, which is concept drift. Mm-hmm. So we see this a lot because laws and regulatory things change. So FCPA guidelines or carbon emissions or any of the things that change outside that are external to a model being built can create a whole bunch of problems later because of concept drift. And then, on the flip side of that, within the labeling process or when the users are using it, concept drift happens a lot. And I'll give you an example. It's not uncommon for a legal team, once somebody's deposed, to go back and say, well, this issue used to be issue X, but now it's X plus Y because Devon said when he was deposed that no, he always worked with this group and that he always used this table when he inserted it into his code. And all of a sudden you have, 6 months or a year of human labeling that is now drifted from what the real issue has become. So those are some of the things that I would point to as proving that it's fiction, that models never need to change once they're deployed.
That's great. No, and thanks for breaking it down into sort of those four key points. What's the bigger implication of such a concept drift or degradation of model, especially in your space? A lot of effort is spent into building these models. A lot of effort is spent into monitoring these models, but there's still an implication of this degradation. What would you say that is in practical terms?
Well, two things. In litigation environments and disputes, it's mostly looking backwards, right? But these things take forever. So a big corporate lawsuit could take years. I'm working on some major antitrust cases, and the governments charge people criminally and there's civil lawsuits. And so just the nature of how long it takes is going to bring that into play because things change. And so you have to go back and look backwards yet again. Mm-hmm. In compliance, you're looking at, take the Citi Bank world, they're looking for suspicious transactions, and they build a model that first of all looks backwards so you can train looking forward. And then all of a sudden something changes and the, financial regulations change and your go forward features and functionality become all wonky because you built your model based on the past as a predictor of the future, and the SEC changes something.
That makes sense. Great. Well, Sourabh, I want to ask you a quick question on the similar topic. So is it a fact or fiction that it's very easy and quick to adapt models that are built for one use case to another use case, especially in a regulatory environment?
That's a fiction for sure. So yeah, I mean, as much as data scientists and the senior management would want to reuse models to avoid cost and whatnot, but it's just not possible specifically in a regulated environment like bank. I can give you a couple of examples. Like, so you build a credit decisioning model that's based on US customers, and you're using it for US customers. You can't use that same model to do credit decisioning for APAC or EMEA customers because the customer profile is different. The use case is still the same. You still are doing credit decisioning, but because the customer base and the customer profile is different, that model cannot be used, right? So that's an example of why you cannot lift and shift a model from one use case to another use case. You could also use some geographies might allow you to use features that are okay. So a feature such as maybe age or something is okay in China, but may not be okay in the US, right? So that's another example of you can't lift and shift. Then you also have these concepts of pre-trained models like GPT-3, BERT, for NLPs, or VGG, ImageNet, ResNet for images. So again, a lot of the enterprises are using these pre-trained models out of the box. But again, even then, you still have to train the last few layers in these models to your specific use case, right? So for example, as Richard was saying, if you're using these models to analyze legal documents, right, so that the model that has been trained is generic enough, right? So it doesn't understand legal terms and the lawyers speak to a great extent. So you have to train and make it specific to your use case, right? So I think in general, in general, I mean, there could be some unique scenarios where maybe some aspects of the model could be reused. But I think if you are intending to reuse a model, you need to be aware of the model limitations. You need to understand the training data sets that were used to create the model in the first place. And you have to explain to the regulators what's behind the scenes of the model, like how is the model functioning. Can you explain the underlying logic or underlying the training data set that was used? So as long as those aspects of the model are taken care, maybe there are some outlier scenarios where maybe you can use. But I would say with 95 to 98% of the times, every model, even in our bank, they require a revisit of the model classification and then the model build criteria, right? So we evaluate every model in its own merit for that specific use case, and then put them in prod. So yeah, reuse is a myth, but hopefully maybe one day the techniques are advanced enough so that we can maybe borrow some of those ones for reusing.
Yeah, for sure. There's a lot of interest and excitement about large language models. We've been hearing quite a bit from very large companies. I just saw something that was published about Meta this morning. So, what is your take on putting large language models to use? As you said, that there's some amount of transfer learning that needs to happen, and then there's of course understanding and explaining the model itself. But do you see us heading down a path where large language models and the work that's done behind it can be put to an enterprise use in the short future?
Yeah, I mean, not as it is out of the box. I think there has to be a bit of custom training that needs to happen for your specific scenario, right? So, for example, the industry is going gung ho with the Google's ImageN or the DALI to where it takes a text, converts it into images. And if you look at some of those examples, if you give a text, say a nurse operating with a doctor in a hospital room, invariably the nurse is a woman, right? So again, it's because the models have been predisposed and trained with publicly available data. Now, if you employ that model in, say, the NLP part of that model in a chatbot setting, and if it's chatting with someone and then that customer identifies themselves as nurse, the model might assume that it's a she, and the conversations might differ, right? So again, we have to be very careful with how we implement a pre-trained model, and you always have to look at your use case, what your end game is, and whether the model fits with that with that end game.
Makes sense. Richard, I want to ask you a question that was posed by the audience. So here's the question: how to convince your organization to move from legacy machine learning system to a data-centric one? The difficulty lies in the fact that dev team is relatively small and has existing infrastructure. And would love to hear from you. Sourabh, you could also chime in if you have.
Yeah, that's a great question. I'm sort of dealing with that in my own organization right now. And when I'm looking at it, has existing infrastructure is probably the one thing that, yes, we have existing infrastructure, but I wouldn't say that that's the limiting factor. The limiting factor is in a lot of professional services environments, if you get better at predicting what the professionals should look at, how many professionals do you need? So for law firms, this is a key issue, which is if all of a sudden I only need 2 lawyers to review 25,000 documents so that we can give the government 2 million, then what happens to the model that says we make our money in the business world by having 10 humans do this thing, right? And so organizationally, there's a big culture shift, and a lot of it gets driven by the clients who figure out, wait a second, I don't want you to have 10 lawyers as an example working on this, but within the framework of a professional services organization, you have to get management to buy into the idea that not only is this going to happen whether you want it to or not, that there's an advantage to being a market mover and getting here first. We're doing that by talking with people like you guys to really shift our IT infrastructure faster so that we can take advantage of getting to the right solution for clients. So I don't know if that answers the question, but those are
absolutely. No, thanks for sharing that. Saurabh, anything else that you would want to add? Of course, you might have your unique challenges given that you work with such a large organization.
Yes, I mean we are also in the same boat as Richard said. We are trying to transform ourselves from being model centric to data centric, and it's a similar set of challenges. I think we have to impress upon. My take is that we have to impress upon the tech orgs that or the model orgs that once you reach a plateau with the model development, the model, you can improve the model only to a certain extent, and then you plateau out. The next thing to look after that is the data. If you don't feed quality data to the model, it's just not gonna magically improve, right? So I think you look at the inflection point where the model, you're doing everything, but the model performance is limiting. It's not going up anymore, and that's the inflection point when you start looking at the data, and then the data will help you improve your model performance.
That's great. We have maybe time for one more question, so I'll ask the same question to both of you. The role of subject matter experts, right? There's still quite a bit of reservation in terms of confidence in results that are produced by AI applications or machine learning systems. What role does collaboration with subject matter experts play in increasing that confidence with end users about the results? So Richard, if you would want to go first.
Yeah, sure. That's great. That's an absolutely great question. For most people who think about AI or interact with it in their daily lives, the purpose or the goal is to make something more popular, to predict popularity so that more people use it. In the world that I deal with, and I'm sure in Citi's world is somewhat similar, we're trying to find the 1% of stuff that's important and isn't really popular because it's problematic. And the only way to do that, in my opinion, is with semi-supervised learning. And then, the only way to make that work is to have subject matter experts who give you labels back, and then you rerun a model and say, okay, you told us these were 15 suspicious transactions. We predict you need to look at the next 200 in this order, right? And without subject matter experts, you'll never get to the right answer. We're producing millions of documents and withholding 7, 10, 12,000 as privileged documents that are documents where lawyers are giving advice. And the only way to do that is to have lawyers go through and say, these 5 documents are privileged and these 10 are not, and then for us to iterate a model. So without their involvement, I don't think, in at least my business, you'll ever get success.
Yeah, no, that makes sense. We've seen the same across many other industries too. For example, insurance has the same, where underwriters need to be involved. Of course, in medicine, doctors need to be involved. And we're going to hear from Memorial Sloan Kettering in the very next session. Saurabh, while we have 30 more seconds, if you wanted to add some more about subject matter experts.
Yeah, I would just add that you have to talk to the right subject matter expert, right? So even today, without AI, there are variances between what 2 SMEs might say about a given set of input, right? So someone has to break the tie, if I may. So identifying who is the right person who would take this call, and maybe it's someone who is more senior, because most often what we have realized is some of these labeling tasks get assigned to someone who is lower in the org, and he or she may or may not understand the implications of how they are labeling. So I would say engaging someone senior is of paramount importance, because they understand the process and they understand the implications.
No, that makes sense. And that last comment was really exciting to do inter-annotator agreement, because with using something like Snorkel, you can adopt a programmatic approach to labeling that inherently does this conflict resolution between different types of label data. So excellent. Well, thank you so much. I want to invite Aarti back, and Sourabh and Richard. Again, I want to thank you so much for sharing your insights, your tips, and spending time with us.
Yeah, likewise. Thank you.
Thank you.
Thanks so much, Devang, Richard, and Sourabh. This is a really amazing discussion.